Okay, so second problem on the tutorial. This looks a little bit different, but it's actually the same problem. The difference is, at least computationally, the difference is going to be that in the first problem I gave you, the sample sizes, the sample means, and the sample variances, those were calculated for you. In this case, what's required is that you would have to calculate the sample sizes, which you can see is 5 per group, but also the sample means and the sample variances for each of the groups. Typically what I do on an exam is I will give you 2 of the means and 2 of the variances and then have you compute the third one just as a review of computing means and variances, and then move on to the Anova problem per se. So I think what I want to do now is just say, I think I will just for group A, I'm just going to tell you the sample mean for this group is equal to 82. And the variance for this group is equal to 41.5. And for group B, the sample mean is 77. The variance for group B is 45.5. Now I'm going to work it out for the last one here. You probably should go back and make sure that you can compute the means and the variances of those first 2 groups. Or certainly if you lack any confidence in whether or not you can do that, you should do it and then check your figures next to mine. And I need to make sure I have all of the subscripts on there. So anyway, add those up, I have 450. So x bar C is equal to the sum of the x's, and yes, I would like for you to write the formulas. If you were going to write them 3 times, once would be enough, but certainly if I give you 2 of them, on the third one you could do me the service of making those calculations. So x bar C is equal to 90. As we have done so many times, we'll get the deviations, and then we'll get the squared deviations. So 95 minus 90 verify that that's 0. That comes out to be 64. And then the variance. Be careful here because it's been my observation from past performance that almost everybody, after they've worked this problem 2 or 3 times, not everybody, but almost everybody, can actually work the Anova problem quite well, at least down to the Hsd stuff. That does seem, based on past experience, to give some people a little more trouble. But of the first part of the problem, it's actually the computation of variance that gives some people a problem, and I'll explain why in a second here, or why I think that might give people some problems. Because there it is, just take the sum of the squared deviations, divide by n minus 1. The mistake that gets made not necessarily frequently, but with more frequency than I like for it, is people will take the square root of this. Obviously, we've been computing standard deviations throughout the course, and but now it's variance, it's analysis of variance, so don't take the square root. I think if you're just careful on that and make sure you divide by n minus 1. Sorry about that. Well, if you're listening to this and that cough's still in here, I apologize. Eventually I'll edit that out. But so it goes. Well, anyway, be careful when you compute the variance. Make sure you don't take the square root. Make sure you divide by n minus 1. So once we have it to this point, the problem is exactly the same as the first tutorial. And I'm going to go ahead and just scroll this up a bit and proceed. Okay, so I think I'll rewrite up here X bar A. I know you already run on your sheet, but just so I can refer back to it here. Okay, so HO, mu A equal to mu B equal to mu C. HR, at least one of the following is true. Mu A not equal to mu B. Mu A not equal to mu C. Mu B not equal to mu C. I'm going to reject HO if F test is greater than some value. Our degrees of freedom for the numerator, k minus 1, 3 minus 1 is equal to 2. Our degrees of freedom for the denominator, total sample size minus k, which is 15 minus 3 is equal to 12. So to your F table, 2 and 12 degrees of freedom, you should see 3.9. And then the F test is going to equal mean square treatment divided by mean square error. Not what I want. Hope I didn't mess this up. Well, awesome. Well, surprisingly enough, I have it writing again. Well, anyway, there we go. MSE calculate here. Okay, it's not writing as well as I'd like for it to, but S squared A, S squared B, S squared C divided by K. That's equal to 41.5 plus 45.5 plus 16, all of that's divided by 3. And that comes out to be 34.33. And so that's what's in the bottom of here, 34.33. I think what I'm going to do right now is I'm going to tell you what MSTR is, finish this part, clear the ink, and then I'll do the calculation of MSTR. So for right now, let me just say MSTR is going to come out to be 215, and that when we get that, we will get 6.26, which is greater than 3.9. So we're going to reject HL and conclude that at least one of those is true. Like I said, in a second I'll get the MSTR calculation for you, but I think I want to get all of that on just this sheet. Okay, so as promised, we calculate MSTR for you. NA x bar A minus x bar bar squared, and then just repeat the same thing for group B. And then again for group C. All that's divided by K minus 1. So we had 5 observations in group A. Okay. You can see now I need to get x bar bar before I can finish my calculation. That was 82, by the way. But x bar bar was equal to x bar A plus x bar B plus x bar C divided by K, and that is 82 plus 77 plus 90, all of that divided by 3 is equal to 83. So now back up here to the MSTR. 5 times 82 minus 83 squared, plus sample size for group B was 5, and its mean was 77, so minus 83 squared. Again, 83 is just the x bar bar down here. Plus 5 in group C, and its mean was 90, so minus 83 squared, and all that's over 2. And so that is equal to 5 plus, let's see, 6 squared, that's 180, plus then 7 squared, 49 times 5, that's 345. Divide all that by 2, and you will get the 215 that I put on the previous, at least previous page of what I'm doing. Okay, now for the Hsd test. Again, I'm going to start with, we've concluded at least one is true, or at least one of the following is true. Mu A not equal to mu B. Mu A not equal to mu C. Mu B not equal to mu C. So we're going to get the absolute value between the corresponding sample means. And for A and B, those were 82 and 77. So they differed by 5. X bar B minus X bar C. That one's 82 minus 90. So B and C differed by 8. Sorry, that should have been X bar A minus X bar C. Had the subscript wrong on that one. This one's X bar B minus X bar C. And so we have now 77 minus 90. That's a difference of 13. So these are in the difference between each pair of sample means, between A and B, A and C, B and C, without regard to direction. We just got the absolute value. So now we need to compute Hsd, the honestly significant difference. And that's equal to Q times the square root of MSC over the size of each group. If you wanted to put NA or NB or NC there, since they're all the same, that would be fine with me. But it's the group sample size. And so the degrees of freedom, I'll write this up here, for the numerator is just 3. For the denominator, you can go up and look at the other one, or you can recalculate it again here. It still is total sample size minus K, or 15 minus 3 is equal to 12. So anyway, our Q value then is going to be 3.77. Make sure you're looking in the Q table and not the F table. And the MSC, which we had calculated a little while ago, was 34.33. And the group sample size was 5. And when you get all gets said and done, that is 9.88 approximately. And so I'm going to take that 9.8 and I'm going to compare it to the differences that we did get between sample means. And only one of those exceeds the 9.88. So the only difference between population means that we can discern statistically is the difference between groups B and C. So we can say, if we just look at the direction of this, the mean for Plan C, which was profit sharing, productivity was higher when you had profit sharing than when it was a salary. But incentive plans really were not different from either of the other two. The only difference we could say is between profit sharing and salary. So if we want to know which of those to prefer, at least in this particular setting, we should prefer profit sharing. If the only outcome we're interested in is productivity. Of course, there are all kinds of other reasons you might use any one or more of these. Well, that'll be it for this one.